Okay, so something huge is happening in the world of robotics right now. We're talking about a leap so big, it's going to take robots from behind factory walls and put them right into our living rooms. So today, we're going to dig into the incredible breakthroughs in both the brains and the bodies that are making all this possible, way faster than you might think.
All right, let's just set the stage here. For decades, when you heard the word robot, you probably pictured that thing on the left. Some giant, clunky, expensive arm doing one repetitive task over and over. But that's the old way of thinking. The new vision? It's all about robots that are smart, that can adapt, and are actually affordable enough for you and me. So how do we get there? Well, it all starts by giving them a completely new kind of brain.
I mean, just think about your house for a second. It's chaotic, right? Things are never in the same place twice. It's not a sterile, predictable factory floor. For a robot to actually be useful in a place like that, it can't just follow a script. It needs to understand the physical world, to learn and react on the fly. And believe it or not, that's exactly what's starting to happen inside the robot's brain.
So check this out. A team of researchers in China just dropped what they're calling the WOW model. It stands for World Omniscient World Model, which is a mouthful, I know. But the key takeaway is that this might be the world's first self-evolving world model. It's designed to give robots a genuine sense of physical intuition, almost like the kind we have.
So you're probably asking, what the heck is a world model? Well, think of it like this. It's like the AI has a little physics-based video game running inside its own mind. Instead of just watching a million videos of a ball dropping, it builds its own little simulation to figure out why the ball drops. It's not being fed the rules of gravity or friction, it's learning them by running these little mental experiments over and over. That's how it develops a real gut feel for cause and effect.
And we're not talking about some little side project here. The WOW model is a massive generative AI with 14 billion parameters. You can think of those parameters as all the little knobs the AI can tweak as it learns. Having that many allows it to build this incredibly rich, nuanced understanding of the world. It's that sheer scale that lets it get so good, so fast.
And the way it learns is just genius. The team calls it the Sophia paradigm. And it's this really elegant loop. First, it predicts. Okay, if I push this glass, what happens? Then it critiques its own prediction. Would it really slide that way or just tip over? That doesn't look right. And finally, it refines its internal model. This simple loop of predict, critique, refine lets it learn from its own mistakes, getting smarter with every single attempt.
And this is the real game changer. The creators literally call this the missing link. See, we already have AIs that can talk about the world, right? Your chatbots. But this is the bridge to what they call embodied intelligence. AIs that can actually live and act in the world. They're not just processing text anymore. They're processing reality itself. So, you've built this amazing new brain. But how do you prove it actually works? How do you even test for something like physical intuition? Well, you can't. So the team had to build a whole new benchmark from scratch to do it. And guess what? The WOW model is already crushing it, hitting top scores and proving it has a far better grip on reality than older models.
So we've got this incredibly powerful new brain. Fantastic. But a brain on its own can't do much, right? It needs a body. And this brings us to the second half of the story. Because what's so wild is that at the exact same time all this AI work was happening, the hardware side was having its own quiet revolution.
So I want you to meet Boommy. It's a new humanoid robot from a startup, and what makes Boommy a huge deal isn't its power or speed, it's the fact that it's being designed from the ground up to be the first truly consumer-grade humanoid. For your home, for a classroom.
Now that phrase consumer grade gets tossed around all the time, but let's cut to the chase. What does it really mean when we're talking about price? What do you think a walking, balancing humanoid robot actually costs? Seriously, take a second and just guess. Whatever number you have in your head, you're probably way off. There it is, $1,370. No, that is not a typo. Just let that sink in for a moment. This isn't a $10,000 lab experiment anymore. This is price for a living room. That single number changes everything about who gets to own and create with this technology.
And to really hammer this home, just look at this comparison. We are talking about a cost that is basically the same as a new high-end smartphone. Now compare that to a typical industrial robot arm. It's not even in the same ballpark. This is that moment, that specific inflection point where a technology jumps from a niche industrial tool to a mass market product. And it's not just the price. Everything about it is designed to be friendly and approachable. It's small, it's light, you don't need a PhD to program it, you can use simple drag and drop blocks or just talk to it. See, the goal here isn't to build a powerhouse. The goal is mass adoption, getting this tech into the hands of kids, students, and hobbyists.
So that's one end of the spectrum, making robots accessible and cheap. But at the very same time, on the complete opposite end, we're seeing these insane displays of high-end power and control that are just as revolutionary.
Get this, a team took this robot, the Unitree G1, it only weighs about 77 pounds, and had it pull a car. A real 3,000-pound car. I mean, the power-to-weight ratio is just mind-bending. But you know, the truly impressive thing here isn't just the raw strength, it's the control. To pull that car, the robot had to lean back, constantly adjust its balance, and make these rapid-fire foot movements just to keep traction. And that's not just a cool party trick. That's the exact kind of real-world skill a robot needs to, say, carry your groceries up an icy driveway without falling. Okay, so let's zoom out for a second. We've got these two amazing things happening at once. You have AI brains developing real physical intuition, and you have robot bodies getting both incredibly affordable and incredibly capable. And right now, for the first time, those two lines are finally starting to cross. And the timeline for this convergence is just wild. Right now, this is all pretty much in the lab. But experts in the field are making a really bold prediction that by 2026, I mean, that's less than 2 years from now, we could see the first robots with genuine autonomous usefulness in our homes. This isn't some 10-year sci-fi forecast. This is the very near future.
And this is the ultimate takeaway. This is the whole story right here. For years, we've been working on the brains and the bodies separately. But now, we're seeing the perfect storm. An intelligent, intuitive brain is finally meeting an affordable and capable body. That's the magic formula. That is the combination that finally unlocks the door and brings these things out of the lab and into our lives.
Which of course leaves us with one last kind of huge question. For so long, this was all pure science fiction, but it's not anymore. It's becoming an engineering problem. And as we solve it, as these robots get good enough to actually cook a meal, do the dishes, fold the laundry, we have to start asking ourselves a much bigger question. When the robots can do all that, what are we going to do with all our time?